in neutral geometry, we have a big proof after we've proven Saccheri quadrilaterals. So this proof states if ABCD is a Saccheri quadrilateral with base AB, then we have the following. So our hypothesis here will prove number 1 here. After we've proven 1, then 2 can be proven, and so on. So this goes on for 6 statements, but today we'll just be showing how our hypothesis, which is if we have a Saccheri quadrilateral, shows number 1, that the diagonals AC and BD are congruent. So just a few things when we are in neutral geometry. Some things that we know are true are that the angles of a triangle will sum to less than or equal to 180, and the angles of a quadrilateral will sum to less than or equal to 360. So remembering what a Saccheri quadrilateral is, it is a quadrilateral here, ABCD, where the 2 base angles are 90 degrees, and we know that the 2 sides with those angles that connect to the base are congruent. So here we have AD congruent to BC, and here we have angle A as a right angle and angle B. And it is also good to know that the 2 top angles are called summit angles. So now proving that our hypothesis, which is we have a Saccheri quadrilateral, we can show therefore number 1 that the diagonals AC and BD are congruent. So if we go ahead and draw a quadrilateral, we can go ahead and add the features that these are 90 degrees and these are congruent. So these are the features of a Saccheri quadrilateral. So we have base AB. So from our hypothesis, we can go ahead and show that our diagonals, which are AC and BD, are congruent. So first off, we know ABCD is a Saccheri quadrilateral. For 2, we know that AC and BD are the diagonals. Thirdly, we can now have congruent triangles by side angle side. So if we see triangle ABC right here is congruent to triangle BAD, which is this one right here. And we know that by side angle side. So triangle ABC is congruent to triangle BAD by side angle side. So if we go ahead and look, we have these 2 sides congruent right here. So that gives us our first side. We have the base, which belongs to both triangles. So that gives us our second side. And we also know that between those 2 sides, we have our 90-degree angles right here. And we know that those are congruent. So therefore, our 2 triangles are congruent. Then for number 4, therefore, we know that AC is congruent to BD, which are diagonals, and we know this because of the definition of congruent triangles. Since we already proved that those triangles are congruent, we know that every other part should also be congruent as well.